Welcome. In this video, I will talk about the concepts and problems related to linear dependence and independence of vectors. So let us start the video. First of all, let us look at the definition. Let v1, v2, v3, vn be a set of n vectors. The set of vectors is said to be linearly independent if a1 into v1 plus a2 into v2 plus a3 into v3 and up to an into vn. So this kind of expression is known as the linear combination of this set of vectors. So if this linear combination is equal to 0, then if it implies that all the scalars a1, a2, a3 up to an are 0, then we say that this set of vector is linearly independent. If at least one of them is not 0 or some of them is not equal to 0, then they are said to be linearly dependent. So we will use the concept of rank to find the idea that whether the given set of vectors are linearly dependent or independent. So you can look at this. It is given here that we can use the concept of rank of a matrix to decide whether the given set of vectors are linearly independent or linearly dependent. So what is the process? The process is that we form the matrix with each vector which are given here as its row and reduce it to the row echelon form. So the first step is to form a matrix by placing all the vectors as its row and then reduce the matrix in row echelon form. The given vectors are linearly independent if the row echelon form has no zero row. Right, means if the row echelon form has no zero row, means what? That rank of the matrix that is formed by placing those vectors as its row is equal to the number of vectors, right? So in that case we say that the vectors are linearly independent. But if I get some zero row, means if rank is less than the number of vectors, right, then we say that these vectors are linearly dependent. There is an easier way also, especially in case of a smaller system of vectors. So in case if matrix formed is a square matrix, then we can decide the linear dependence and independence by evaluating their determinant. So what we do, we form a matrix and then we calculate its corresponding determinant value. If determinant is equal to 0, then vectors are said to be dependent, and if determinant is not equal to 0, then vectors are said to be independent. It is very easy to remember it, and to remember it you can use an analogy that if you are a 0, you are dependent on others, means you are dependent. If you are not equal to 0, means if you are non-zero or not equal to 0, then you are independent. So in life also, if you want to become independent, you have to become not 0, means you have to become hero. Now let us solve this problem. Examine whether the following set of vectors is linearly independent. So as I explained, if you have not understood in the previous slide, you will understand here that what I am going to do, I am going to form a matrix A. How do I form the matrix? By placing these three vectors. So in the first row I place the first vector, that is 1, 0, 2. In the second row I place the second vector, that is 3, 2 and 4. In the third row we place 1, -1 and -1. Right. So since this is a square matrix, what we can do, we can find its determinants, and if the determinant will be equal to 0, it will be dependent. If determinant is not equal to 0, it will be independent. So let us evaluate the determinant. So I am expanding it about the first row. So 2 into -1 is equal to -2 and +4. then minus 0, so no need to write, and then plus 2, and here if I evaluate 3 into minus 1, that is minus 3, and 2 into 1, that is 2, so I write minus 2. So what we get here, we get minus 2 plus 4, that is 2, and minus 5 into 2 is minus 10. So what we get is minus 8, means which is not equal to 0. So it means what? That this set of vectors are linearly independent, and in short I can write them as Li. So we will not write linearly independent, I will simply write linearly independent as Li. So this is the first way, and especially if the matrix is a square matrix, we can use this. But I also want to show you that if I reduce this matrix into row reduced echelon form, its rank will be 3, right? That I want to show you. So by if the rank is equal to the number of rows, means if the number of rows here are 3 and rank also I get 3, so these 3 vectors will become linearly independent. So let us check it. So to reduce this into row echelon form, you already have a 1 here, so you are going to make this element and this element 0. So for that you can replace the second row R2 by R2 minus 3 times R1, and you can replace the third row R3 by R3 minus R1. So if you do that, you get a vector, that is you get a matrix, sorry, 1 0 2, and here you get 0 and 0, and 2 minus 3 times 0 is 2, 4 minus 3 times 2, so 3 into 2 is 6, 4 minus 6 is minus 2. And here what do you get? You get 1 minus 1 0, minus 1 minus 0 is minus 1, and here you have minus 1 and minus 2, so what you get is minus 3, right? Now we need to perform one more step, because below this I already have made everything 0. Now I have to make everything below the element 2 0. And what is row echelon form, I hope you understand, because I have already uploaded a detailed video for understanding the concept of row echelon form. So I have to make this 0, so I can replace the third row R3 by R3 plus 1 by 2 times the second row, that is R2. So what I will get? I will get 1 0 2 0 2 minus 2, and if I multiply it by 1 by 2 I will get 1, so I will get 0 0 and minus 3 and minus plus 1 by 2 into minus 2, means I will get here minus 4, right? So what you notice that this vector has this row echelon form, I am constantly calling it vector. So this is a matrix. In this matrix the first row is not 0, non-zero row, second row is non-zero row, third row is non-zero row, this is 4. So let me write it better, because people may be confused. This is basically minus 4, right? Minus 4. So this is also a non-zero row. So what is the rank of this matrix? Rank is equal to 3, which is equal to the number of rows in this matrix. So it means that this set of vectors are linearly independent. So I have used two different methods to decide that whether the given set of vectors are linearly dependent or independent. Okay, so I am going to take more problem, but before that I want to highlight, you may be having this question in your mind, that what does it basically mean for the vectors to be linearly independent, right? I repeat my question. The question is, what does it mean if I say that these three vectors are linearly independent? It means that if you take any of the vector, for example if I take the third vector, that vector cannot be written as a combination of other two vectors, right? Similarly, if I take this vector cannot be written by any means as a combination of these two vectors. So I just want to show you that also. So let's show that here none of the vectors out of these three vectors can be written as a combination of other two vectors, and if it is not possible to do that, that means that these three vectors are linearly independent. So let us verify that also. So let me take the second vector. You can take any one, but I am taking the second vector, 3, 2 and 4, and I am trying to write is as a combination of these two vectors. So what do you mean by combination? This combination as a means linear combination. So I am taking alpha times the first vector 1, 0, 2 and plus beta times this vector, that is 1, minus 1 and 1. If it is possible to get a value of alpha and beta, so that this vector can be written as alpha times this vector plus beta times this vector, then these three vectors will become linearly dependent. But we already have seen that they are linearly independent. So let us establish this. Just to prove it, I am doing this exercise. So if you look at this expression, this is actually 3, 2, 4, and in the right hand side, if you combine them, you will get what? You get alpha from here and plus beta from the second term. So alpha plus beta. If you multiply alpha into 0, you will get 0, and beta into minus 1 is minus beta, so you will get minus beta. And from the third, you will get 2 alpha minus beta. So if I compare this, I will get alpha plus beta is equal to 3. I will get beta minus beta, is equal to 2, and I will get 2 alpha minus beta is equal to 4. So I already have got the beta value. From this equation I can get alpha also. So that is 3 minus beta. So that is 3, and beta basically is minus 2, right? So 3 minus beta means 3 plus 2. So we get what is 5. Now if you substitute this value of alpha and beta, we will notice that this equation will not be satisfied. So what is 2 times alpha? 2 times alpha is 2 into 5, and minus beta means minus 2, which is equal to 12, which is not equal to 4 as it is given by this equation, right? So it means what? That this system of equation does not have any solution, right? This is an inconsistent system. It means that we cannot find any value of alpha and beta. We cannot find alpha and beta such that this condition, that 3, 2, 4 is alpha times this plus beta times this, is satisfied. So it means that these three vectors are linearly independent vectors, right? Now I hope you have understood the meaning of linearly independent vectors. So let us take few more problems to understand this concept better. So now let's take this problem. So what we need to do to check whether this set of 4 vectors are linearly dependent or independent. So what I have done already, that I have placed these 4 vectors as 4 different rows of a matrix, right? Now since this is a 4 cross 4 matrix, so it will be time consuming to evaluate its determinant. So I am not evaluating the determinant, I am reducing it into the row reduced echelon form. So to reduce it in row reduced echelon form, we have a 1 here. We need to make every other element below this equal to 0. So what operation should I perform? I should replace R2 by R2 minus R1. We need to replace R3 by R3 plus R1. We need to replace R4 by R4 minus R1, right? So what I will get, let me draw the matrix first. So I will get 1, 1, 0, 1, then this 3 will become 0, 0, 0, and 1 minus 1, so this term will also be 0, 1 minus 0, so this will remain 1, 1 minus 1, so this will also become 0. And if I have added, so this is 0, 1 plus 1 is equal to 2, 1 plus 0 is equal to 1, and 1 plus 1 is also equal to 2. And if I look at the third one, 1 minus 1 is 0, 0 minus 1 actually is minus 1, 0 minus 0 is 0, and 1 minus 1 is also equal to 0, right? So this is the first step where I have reduced all the elements below the pivot element equal to 0. Okay, So what should we do next? So below the first pivot I have already made everything 0. Now I go into the second row, I come across a 0 term here. So it means what? I will look down the column and find a non-zero element. So we come across a non-zero element here. It means that in the next step, which I can write here, I am going to reduce I am going to bring this 2 in place of the 0, means I am going to basically do the row exchange. So I am writing here, I am replacing R2 and means I am interchanging R2 and R3. So if I do that, what I will get? I will get 1, 1, 0, 1. And students, you need to know that this is a very specific algorithm. We are not doing any random operation. In case if you have understood the concept of rank from someone else or some other source, make sure that you are following the algorithm. And algorithm is that I am explaining here, that I am trying to first fix the pivot, making everything below that 0, and then getting the next pivot in the appropriate place. So here I am going to write it as 0, 2, 1, 2, and then 0, 0, 1, 0, and then 0, minus 1, 0, and 0. Right. Now below the second pivot I have to make everything 0, but we have a non-zero element here, means we have to make this 0. So how can we make this 0? We can replace the fourth row by fourth row plus half times the second row. Right. So this will give me what? This will give me 1, 1, 0, 1, 0, 2, 1, 2, 0, 0, 1, 0, and it will be 0, right? And this will also become 0, and if you multiply this by half, it will be 1 by 2. So 0 plus 1 by 2 is 1 by 2, and if you multiply this by half, it will become 1. So it will become 1 here. Right. Now below the first pivot every element is 0, below the second pivot every element is 0, below the third pivot there is a non-zero element, so I have to make this 1 by 2 also 0. So how can we do that? We will be doing the next operation, which I am writing here because I want to write the matrix. So let me change the color also, so that you don't have any confusion. So what I am going to do, I am going to use the operation R4. This is the fourth row, so basically I need to write here. Okay, or let me actually continue this side only. So R4 goes to R4 and plus, or sorry, minus 1 by 2 times R3. I hope you got this, because if I multiply it by 1 by 2 it will become 1 by 2, and if I subtract it, it will become 0. So the last matrix that I will get is 1, 1, 0, 1. This operation I have performed here, and 0, 2, 1, 2, 0, 0, 1, 0, and 0, 0. This will become 1 by 2. 1 by 2 minus 1 by 2 is 0, and 0 multiplied by 1 by 2 is 0. So 1 minus 0 is 1. So what we have got in the end is an echelon form. Now it is an echelon form. You can see below first pivot everything 0, below second pivot everything 0, below third pivot everything is 0. So there are 4 non-zero row, which is equal to the number of rows in the matrix formed with the help of these 4 vectors. So since the rank of this matrix is 4, which is equal to the number of rows in this matrix, so it means that these vectors are linearly independent vectors. Okay, I hope up to this things are very clear. Now let us, and I hope you also are clear that if you take any of the vector here, you won't be able to write any of the vector as a combination of other 3 vectors. So you can verify it yourself, just as an exercise, that if you try to write, for example, the last vector 1, 0, 0, 1 as a combination of alpha time the first vector, if I call this vector v1, this vector as v2, this vector as v3, and this vector as v2, v2 v4. So I am trying to write the v4 vector as alpha times v1 plus beta times v2 plus gamma times v3. So you won't be able to find alpha, beta, gamma here because they are linearly independent. Okay, let us do this problem quickly. Right, problem solving is important. I think the concepts I already have elaborated, but to be very thorough with the concept, the many number of problems you solve, the better it is. So I am going to first form a matrix by placing all these three vectors which has 5 component as 3 different rows. So 2, 3, 6, minus 3 and 4. Then we have 4, 2, 12, minus 3 and 6, and we have 4, 10, 12, minus 9 and 10. Now I think it is very obvious that we have a non-zero element here, which is the first non-zero entry in this row. So this becomes the pivot. I have to make this 0 and I have to make this 0. So to do that, what I am going to do, I am going to replace the second row R2 by R2 minus 2 times R1, and the third row R3 by R3 minus 2 times R1, and I am writing it here so that there is no confusion. So I am writing it here. So 2, 3, 6, minus 3 and 4, and if I reduce it, it will become 0 and 0. Now 2 minus 3 into 2, 6, so I will get minus 4. 2 minus 6 is minus 4. 12 minus 12 is equal to 0. Minus 3 and plus 6 will be equal to 3. 6 minus 4 into 2, 8. So 6 minus 8 is minus 2. Now if I reduce that, 4 minus 4, 0. 10 minus 6 is 4. 12 minus this 12 is equal to 0. Minus 9 and plus 6 is minus 3. 10 minus 8 is equal to 2. Right? Now below this everything 0. I am going to fix this element and going to make every other element below this 0. So this is very simple. We don't have to think much. We can replace the third row R3 by R3 plus second times, R3 plus second row, that is R2. So what I will get? I will get 2, 3, 6, minus 3, 4, 0, minus 4, 0, 3 and minus 2, and here I will get 0, 0, 0, 0 and 0. Right? So let me do one small change here. I write 3 just under this, otherwise it will not look good. So it is 3. Right? So you can clearly see that here the determinant approach will not work because this is not a square matrix, it was a rectangular matrix. Basically there are 3 rows and 5 columns, 3 cross 5 matrix. So there are 3 rows in this, but when I reduced it to row echelon form, I got to last row as a 0 row, means the rank here is equal to 2, which is less than the number of rows, that is equal to 3. It means that these 3 vectors are linearly let me write linearly dependent vectors, linearly dependent. And I leave this for you as an exercise that you can write any of this vector as a combination of other 2 vectors. Right? Let us quickly solve the last problem, one more problem, and to be very clear about the concept here. Right? So the last problem that we have, so here also we are going to do the same thing. We are going to place these 4 vectors as 4 rows. So 1, 1, 0, 1, 1, 1, 1, 1, 4, 4, 1, 1 and 1, 0, 0, 1. And I am reducing it to the row echelon form. So to do that, I need to replace the second row by R2 minus R1. I need to replace the third row R3 by R3 minus 4 times R1, and the fourth row R4 by R4 minus R1. So what we get? We have 1, 1, 0, 1, and then we have 0, 0 and 0, and 1 minus 1 is 0, 1 minus 0 is 1, 1 minus 1 is 0, and 4 times, so this 0, this will also become 0, and 1 minus 4 times 0 will remain 1, and 1 minus 4 times 1 is minus 3, right? And here 1 minus 1 is 0, 0 minus 1 is minus 1, 0 minus 0 is equal to 0, and 1 minus 1 is also equal to 0. I hope it is clear up to this. Yes or no? Let me write it better. Okay, so you noted that I have reduced this everything below this element 0. Now if I go into the second row, we got a non-zero element. So when we get a non-zero element, what we do? We do the we look down the column to find a non-zero element. Sorry, I got a 0 element, so we look down the column to find a non-zero element. So this is also 0, but this is not 0. So it means I will be doing the row exchange. I will be exchanging the second row with the fourth row. So this matrix will become 1 1 0 1 and 0 minus 1 0 0, and then third row is as such 0 0 1 and minus 3, and the last row will become 0 0 1 and 0. Okay, now below this everything 0, this becomes the next pivot. Now everything under that is 0. Now this is the third pivot element, so I have to make this 0. So it is very clear that I can replace that the fourth row by fourth row minus the third row. So what I will get? I will get 1 1 0 1 0 minus 1 0 0 0 0 1 and minus 3, and then this will be 0 0 1 minus 1 is 0, and 0 minus 3 will become plus 3, right? So did you notice that I reduced it to the echelon form, but the number of non-zero row is 1 2 3 4. So the number of rank of this matrix is 4, which is equal to the number of rows n, that is also 4. So it means that these vectors are also linearly independent, and when it is linearly independent, you won't be able to write any of the vector as a combination of other vectors. So I believe that the concept of linear dependence and independence is clear to you. Just I want to do one more thing, because when I was explaining this, that these vectors are linearly dependent, I also want to show you that this vector, any of this vector, can be written as a combination of other two vectors, because that will help you to understand the idea of this. So let me quickly do that as well. So when I say I already have proved that these vectors are linearly dependent, it means what? Suppose I take the last vector and I want to write the last vector as a combination of these two. So basically what I want to write 4 10 12 minus 9 and 10 equal to alpha times the first vector, that is 2 3 6 minus 3 and 4, and plus beta times the second vector, that is 4 2 12 minus 3 and 6. So if I compare them, I am writing it. First equation first will give me 2 alpha plus 4 beta is equal to 4. The second one will give me 3 alpha from here and 2 beta from there. So 3 alpha plus 2 beta, which is equal to 10. I am comparing the vectors term by term. The third one will give me 6 alpha. So 6 alpha and plus 12 beta is equal to 12. The fourth one will give me minus 3 alpha from here and minus 3 beta from there, right? That is equal to minus 9 from here. And lastly 4 alpha and plus 6 beta will be equal to 10. So there are 5 equations in 2 variables, so we should solve any 2 of them. So suppose I solve these 2, and then I will check that whether the solution that we obtain by these 2 will satisfy these 3 or not. So to solve these 2 equations, here we have 2 alpha plus 4 beta is equal to 4, and I want to get 4 beta, so I can multiply it by this equation, the second equation, by 2. So it will become 6 alpha plus 2 into 2 beta is 4 beta, and 10 into 2 is 20. So if I subtract that, what I get? Minus, minus, and minus. So 4 beta and 4 beta cancel. 2 alpha minus 6 alpha is minus 4 alpha, and that is equal to minus 16, means alpha is equal to 4. So if alpha is equal to 4, what is beta? So using the first equation, I can write 4 beta is equal to 4 minus 2 alpha, that is 4 minus 2 alpha means 8, that is equal to minus 4. So beta is equal to minus 1. So we got alpha is equal to 4 and beta is equal to minus 1. You can see that it will satisfy the three equations. So 6 alpha, so if you check the third equation, so 6 alpha means 6 into 4, and minus 12 beta means 12 into 1, so that is equal to 12. So it is checked. If you check the third one, 3 minus 3 alpha, that is minus 12, and minus 3 beta, so minus minus plus 3, that is equal to minus 9. This is also checked. And if I take the last one, 4 alpha means 16 plus 6 beta, that is minus 6, is equal to 10. So that is also checked, means this alpha is equal to 4 and beta is equal to minus 1 is a solution of this. So it means what? That this vector can be written as 4 times 2 3 6 minus 3 4 plus not plus, minus 1 times, because beta is minus 1, 4 2 12 minus 3 and 6. So if you simplify it, 4 into 2 8, 8 minus 4 is equal to 4. Then 4 into 3 is 12, 12 minus 2 is equal to 10. 4 into 6 is 24, 24 minus 12 is 12. 4 into minus 3 is minus 12, and plus 3 is minus 9. And finally 4 into 4 is 16, 16 minus 6 is equal to 10. So you can see that the last vector can be written as a combination of these two vectors, because these vectors were linearly dependent. So by linearly dependent, we mean that given any vector out of the set, that vector can be written as a combination of remaining vectors, right? So this is all about linear dependence and independence. I hope you understood the concept thoroughly. In case if you are coming across the video for the very first time, like it and share with all your friends. Thanks for watching. Have a great day.